Namastey Coders. I hope you are fine. So today is 19th March and we have solved today's problem of the day. The video is getting uploaded on my channel. It is getting uploading, right? So once it is getting uploaded, you can watch the video. So it's time for solving LeetCode 75 problems, and so let me explain you these 75 problems. So these 75 problems are the most important 75 problems of the DSA, which will most probably gonna come into your interviews. So if you want to prepare for your interviews, your placements, these 75 questions are the must. So please please be connected with me through the YouTube. You can subscribe my channel so that you can get these explanation videos regularly. So I have so let me tell you that I have created these two playlists in which I will solve LeetCode 75 series and also LeetCode problem of the day daily, right? So this is the time, and also I have solved all the first problem of every topic till here, right? And we have started with the second problem, and we have already solved the second problem till binary search, and now it's time for second problem of backtracking. Okay, so the problem is, okay, one more thing, along with these two playlists I have also created a WhatsApp channel where you can to build a community of the coders, right? So if you want to be a part of the coding community, you can join the WhatsApp channel. The link is given in the description box. Okay. So now let's start with the problem. The problem is the combination sum 3. Find all valid combination of k numbers that sum up to n such that following conditions are true. Only number 1 through 9 are used, so we can use numbers from 1 to 9. Okay, now each number is used at most once. Okay, return the list of all possible valid combination. The list must not contain the same combination twice. Okay, the combination may be written in any order. Okay, so what is given is we have to find k numbers which is sum up to n, and we can use only numbers from 1 to 9. Okay, so we have to find all such k numbers which will sum up to n, and which has the value from 1 and 9. We cannot repeat the numbers, right? So for k equals to 3 and n equals to 7, there is only one combination, which is 1, 2, 4. Okay, if we use 1, 3, 5, which is up and down, all the other combination will not get valid other than this. For k equals to 3 and n equals to 9, only these three combinations are valid. So the problem is pretty straightforward. We have to use k numbers to sum up to n, and we cannot use our number multiple times in a combination, right? And we have to find all such combinations. Okay, so how can we solve this problem? This is the straightforward problem of backtracing, sorry, right? So of course recursion is getting used in backtracing, that's why it's called recursion, but this is the straightforward problem for backtracing. So what we're gonna do, so let's say we have built a combination till let's say we have built a part of a combination. Now we want to search that what can we put in here. So let's say we have put 1, 2, 3, right? 1, 2, 4, right? Okay, now we can only put 5 because all the previous things are getting used, right? We have already used 3, but with 3 all the cases are not valid, let's say, right? That's why we use 4 here, and then we will start with 5 and we will check for rest of the numbers, right? If the 5 get validate, then we will start with 6. If 5 will not get validate, we will start with 6. If 5 get validate, we will put the that combination in the answer, and then again we will start with 6. So this is the backtracing. So what happened is, we have our previous half of the combination. We are currently at this part, this index, and then we have to find this part of the combination, right? And what we are doing is, we are only we are making the combination in a sorted order. So we will always use greater number here from this part, right? So let's say this is 3, so we will start with 4 and upper, and then let's say we will put 4 here. Then we will check this combinations, and all those combination which is like fulfill these requirements, and these requirements we will put that in the answer, right? This is the temporary temporary means this previous wala part. This is k, and this digit is nothing but this digit, right? Or this digit which we are going to start with. Okay, and after checking with 4, we will check with 5, we will check with 6, and so forth, so that for this part we will check for everything, and then again we will go back and check for this part again with greater number. So let's say this is 3, we will check again with 4 here, and then here also let's say this is 2, we'll check with 3 also. So this is how we'll check with all the combinations, right, which is valid. So what we are doing is, we are making an answer array which is the answer, and we are making a temporary array which is the previous array, right? And we are using a helper function to do the backtracing and recursion. So this is the base case. If the temp dot size is equals to k, if we got all the numbers in temp, right, all the k numbers in temp, and also n is equals to 0, that means we have completed the sum. That so we will put the answer, we will put the temp in the answer. That means the temp is the valid combination, right? For a valid combination, the size of temp should be k, and n should be 0. N means the required sum, right? Because no more sum is required, so no more no more integers are required. Then we will start with the digit, because we have passed the digit here, we have passed 1 here, right? We will go up to the 9, and if I is greater than n, that means okay, so we will start with digit, because a digit is given here, right? And if I is greater than n, that means I is greater than n, that means we cannot add the I in our combination, right? N is required, right? If I is greater than n, some will become greater than required sum, right? So if I is greater than n, we will break this and we'll return. Otherwise we will push the I in the temp, we will add the I in our combination, we'll check for the remaining part of the array. That means we will reduce our sum with required sum with I for the next combinations, for the next part of the combination, and we will increase our I plus 1. So we'll give I plus 1 here, and we'll start with the I plus 1 here for the next iteration, right? And then we'll pot back I, and we'll check for the other I's. So this is the code. This is the code of our solution. I hope you guys find this helpful and understand this solution well. So that's all from my side in this video. Thank you for your time. Thank you. Have a nice day.